Hi guys, I'm Ankita. In this video, we shall see another problem on LeetCode. Binary number with alternating bits. So given a positive integer, check whether it has alternating bits. Namely, if two adjacent bits will always have different values. So what they have given is they have given an integer and we have to represent in binary number and we have to check the binary representation of that number has alternating bits. If we see the binary representation of 5 is 101, you could see 101, they're alternative, right? But when you take the number 7, the binary representation is 111 where there is no alternative bits of 0 and 1. It's a consecutive one or consecutive ones are present, so you return false. And if you check 11 also, it is nothing but 1011. In this, if you see 10 alternative, 01 is alternative, but next when you check 11, this is not alternative bits. So you return false here. So this is a problem we have given. First, let's see how do we represent a given number in binary. So what is binary means? It's nothing but base 2. 2 is the base. So let's say given number is 15. Okay. So you know 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So 2 power 0 is something like 1, 2 power 1 is 2, 2 square is 4, 2 cube is 8 and 2 power 4 is 16. So this is the number. Now how do we represent a given number in binary form? If you take 15, let's say which adding of which numbers in this given range will give you 15. So 8 plus 4 is 12, 12, 13, 14, 15. So 8 plus 4 plus 2 plus 1 will give you 15. So in place of 8, 4, 2, 1 you mention it as 1 and for 16 you mention it as 0 because that's not representing the contributing to the binary representation of the given number. So this is the binary representation of 15. That is nothing but if you neglect 0 it will be 1 1 1 1. Similarly, let's take some other number 9. So in case of 9, so 8 plus 1 is 9. So let me just put a line over here. Okay. So yeah, 8 plus 1 will give you 9. So you'll represent 1 over there and remaining bits will be 0. So this is nothing but 0 will be taken. So 1 0 0 1. This is the binary representation of 9. So you have, I hope you guys have got how do we represent a given number in binary format. That is nothing but base 2. So now how do we check whether the bits are alternative or not? So for that what we'll do is we'll have two pointers. Okay, one is current bit, another is previous bit. So let's initialize first previous bit with the first bit from the, this is MSB, most significant bit and least significant bit. We will initialize previous bit equal to the least significant bit now. So what we'll do is, so 1001 you have, right? How do we get this least significant bit? Whatever given number 9, if you do AND operation with 1, that is nothing but 1001 and with 1. So if you see 1001 AND operation with 1, so rest will be 0 only. So 1 and 1 will be 1 0 0 0 0 0 because if one of them is 0, then the answer will be 0 in the AND operation, right? So when you do AND operation with 1, it will give you whether the given bit is 1 or not, the least significant bit. If in case, let's say it was a number 100 only. So if in such case, if you do AND with 1, so 100 AND with 1, this will be 0 0. So 0 and 1 will be 0, then 0 0 0. So this will give you answer as 0. So if least significant bit has a digit as binary digit as 1, then it will return 1 when you do AND 1. If it is 0, then it will return 0 because 0 and 1 will give you 0. So this is the way we check the least significant bit is. Each bit will be checking. First we'll check least significant bit, whether it's a which number it is. So for previous bit what we'll do is given number and with 1. Okay, so that will do you 9 and 1. So the answer will be apparently 1 over here. So let me just write that as well. We'll keep track of everything. Okay, so this will give you 1. Previous bit is currently 1. This is previous bit, short form, and this is current bit. Next, once you do this, now left shift, not left shift, actually right shift. We have to do right shift of this 9 by 1 position. What do you mean by right shifting? Right shifting is nothing but you are dividing a number. So if you divide 9 by 2, it will give you 4.5, that is nothing but 4. Similarly, if you do right shift of this binary format of 9 by one position, so this will be right shifted. So it will give you 1, 0, 0. So actual this representation number 2 power 0, 2 power 1, 2 power 2. 2 power 2 means here 4. Yes, this is nothing but 4. Got it? So right shifting a number by one position means you are dividing it by 2. If you are left shifting by one position, you are multiplying by 2. So if you are right shifting by 2 times, then dividing by 2 square. So it depends on the how many times you are left shifting or right shifting. So for now, we will right shift the number by 1. So n equal to n right shift by one position. This will give you, instead of 9, it will give you 4. So n equal to 4 now, that is nothing but 1, 0, 0. Now again check in the loop. Okay, now this is previous. Okay, now here, once you done with this, now start the loop while n greater than 0. So currently n equal to 100. 100, not sorry, not 100, 100, because it's a binary format. It's nothing but 4. Okay. So while n equal to 0, now again check the least significant bit in this position, 0. So if you do n and 1, there is nothing but current bit. So now we calculate the current bit. Initially we don't calculate current bit. Initially only the previous bit is calculated. In the loop we calculate the current bit. So n and 1, what will give you? It will give you as answer here 0, and with 1 that will give you answer as 0. Now check, once you find the current bit, is current bit equal to previous bit? Is 0 equal to 1? Previous bit, let's say previous bit equal to 1, okay? 0 equal to 1? No. So this will return false. So return false. The condition won't happen. If in case if it is equal, then you have to return false. That will be the answer. Because that means if previous bit and current bit are equal, they're not alternating bits. Either they can be 0, 0, 0 equals to 0, or it will be 1 equal to 1. So they're not alternative. In such case, you just need to return false. You need not to traverse to the next binary numbers in the given integer. So if this condition doesn't become true, then what we need to do? Then we have to again right shift the given number by one position. This is what we have to do to move to get the next bit. Okay. So when you right shift 100 by one position, it will give you not 100, 100 by one position, it will give you 10. 10 is nothing but actually 4 by 2, that will give you 2. So 2 power 0, 2 power 1, yeah, it is 2 only. So now n equal to, instead of 4, it is 2. So n equal to 2. So once you have this, again 0 and with 1 you have to do. So that, okay. Before doing this, yeah, before doing the right shift by one position, okay. Now once you get to know that current bit is not equal to previous bit, you have to initialize previous bit equal to current bit. Why? This is nothing but initially the number was 1001, right? So this was previous bit and current bit you found here. Okay. So next, for the next loop, it should be 100, right? So this should be the current bit and this should be previous bit. So that's what you're doing. Previous bit will be equal to current bit. This current bit, it will become previous bit and current bit you newly find out. That is what we are doing here. So we have got 10. So this current bit we have to check now. So 10 with 1 will give you what? 0 again. So this is the current bit. So now I have to modify the previous bit to 0 here, and current bit is also 0. So is 0 equal to 0? Yes. Then you return false. That is how you just come out of the loop and you return false. Or if after the loop also you do not, this condition doesn't get satisfied, then it is true. So simple logic, I'll explain once again. So 1001. So each least significant bit you calculate. First you do AND with 1. This least significant bit AND with 1. If it give you 1, then store it as previous bit initially. So next you do the right shift by one position, that will give you 100. Now start the loop. Okay, let's say instead of now start the loop. Now again here you have to check this significant bit. So this is 0. So this 0 you do AND with previous bit. Okay, this AND with 1 will give you 0. So check whether this 0 is equal to the previous bit. If it is equal, then it is not alternative, it is not equal, then what you have to do, this current bit should become the previous bit, and for the next current bit what you have to do, again right shift by one position, that will give you 1 0, and this will be the current bit. Okay, next again you check whether these are equal or not. If in case, let's say instead of 0 this is 1, then they are not equal, 0 and 1 are not equal, because 1 0 and with 1 will give you 0. 0 and 1 are not equal, so in such case this will become now previous bit. Next current bit, for finding next current bit you have to do again right shift by one position, that will give you 1. So now this is the current bit. So now if you do AND with 1, they will give you 1, and here it is 0. Again they are not equal. Again what you have to do, this will become previous bit now, and for finding next current bit, 1 right shift by one position will give you 0. So once you get 0, you come out of while loop, because while loop is nothing but n greater than 0. So you return true later. So quickly we will code this. Let's say int previous bit equal to n and with 1. So n we have to okay, right shift by one position. So this is nothing, n equal to n right shift by one position. A shortcutly I have written n right shift equal to one position. That is nothing but a equal to a plus b. If we write a plus c equals to b, in how we write it, same way this also. So while n greater than 0, so int current bit equal to n and with 1, again you have to do. Next, if current bit equal to previous bit, then just return false. Otherwise what we need to do, previous bit will become equal to current bit, and n will be again right shift by one position. So at last you have to return true if this condition, if the entire loop runs in. Yes, and for Java also same logic, nothing change, same logic. We should submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.